Hello,
Yes, ma'am.
am I audible, Bhavish?
Yes, ma'am.
So, how are you?
Fine, ma'am.
Okay, fine. Bhavish, I will not open my camera because I'm in hospital right now. Okay, just today we will have the NCRT go through. Okay, it's fine. So I hope you can see the screen, right?
Yes, ma'am.
So I'll just go through this NCRT because this NCRT is very important. I think your book is actually NCRT important. Okay, so we will talk. We were on this chapter, separation of substances, right? So in our daily life, so we saw this, right? Do you remember we discussed about how tea leaves are separated from the liquid with a strainer?
Ma'am, yes. Yes, ma'am.
Yes.
Yes.
And yes, so I have also told you this when you are eating some food, if you have some green chilies from curry, some
Ma'am,
curry.
hand picking, ma'am. We'll take.
Yeah, hand picking. Yes, yes. And this is the picture I have given in your exam, but due to some error, it was not showing there. So butter is taken out by churning milk or curd. We use this example a lot, right? And we did this activity, right? I told you this tabular column is very important. We discussed very detailedly about this tabular column, right? And we also saw that we see that before we use substance, we need to separate harmful or not harmful substances that may be mixed with it. So what is the purpose of separation? That also we saw, right?
The
Yes. And the substances to be separated may be particles of different sizes of materials. So we saw those things. Like what is the purpose of separation? These things, separation purpose, and the purpose of which we can do the separation. What do we do with the separated components? These things we saw. Okay, and then very important part is method of separation. Right, we discussed about hand picking, threshing, and winnowing and sieving. Can you tell me very quickly, like what are these four methods? Can you define me these four methods? Hand picking first, threshing, winnowing, then sieving. Bhavesh?
yes, ma'am.
Yeah. Are you hearing me?
Yes, ma'am.
I'm telling you, please tell me, define the hand picking method, threshing method, winnowing method, sieving method. Very definitions and examples.
The method of hand picking is to separate the larger components from smaller components with the help of using our hands.
Yes, very good.
Winnowing means the process of separation to remove the lighter particles from heavier particles.
Mm-hmm.
Threshing means the process of separating grains from stalk with
Very good.
with the help of some with like beating the stalk on the ground with force.
Yes, like this.
Yes, ma'am.
Then winnowing.
Ma'am,
You said winnowing.
ma'am, I think I said winnowing. Yes, ma'am, I said winnowing.
Okay, fine. So I think you can see the definitions, the dark colored ones. So the definitions are very important, and have a look also your book. Okay. So yes, and sieving.
And the process of separating solid particles from fine particles with the help of sieve.
Very good, yes. And the examples are like pebbles and stones are separated or removed from the sand by sieving. That is sieving, and we also saw this process very detailing, right? And then we this example I gave you, I think so. Bring a sieve and a small quantity of flour from the home, and sieve the flour to separate them. We saw this, right? We saw this in the. And I also asked you this question: chalk pieces. Chalk pieces. I also told you, can we separate the chalk pieces from the floor? I asked you, right? It is not possible to separate chalk pieces and the white floor with the help of a sieving, right?
Yes, ma'am.
Now
Because
you know
both
what
are
is,
white
yeah,
in
very
color
good.
and in same size.
Same size, very good. So as you told in the definition, fine particles can be separated from the heavy particles, or you can say solid particles. So when both are fine particles, you cannot use the method of sieving. So sedimentation and decontamination. So I'm asking you one question. So if I'm giving you salt and sand, sorry, not sand, chalk powder and salt, and I'm telling you to separate them, how will you? How can you separate?
Hmm. And with the help of
Hmm? No need to tell some formal definitions. Just normally tell.
and evaporation and condensation.
Okay, how define it briefly. What you will do?
Ma'am, first we will add some water into the flour and chalk mixture.
Very good. Not flour, sand and chalk. So not sand, salt and chalk pieces. Salt and chalk pieces. Both are fine particles, right?
Yes, ma'am.
How can you separate? Yeah.
The chalk will not dissolve. It's an
Very good.
insoluble substance. The salt will dissolve.
Yes.
So first we can evaporate the salt out. So
Yes.
we can separate salt from chalk. Now now we can do filtration to remove chalk.
Very good. Very good. Very good. That is how you will separate chalk powder, the chalk pieces, the dot pieces, chalk powder from the salt. Okay, then we saw this sedimentation, decontamination, filtration very briefly. And these three methods are very, very important. Okay. I want you to read this, Bhavish, because no, your book consists of good definitions. I want you to read out. Please read out from sometimes like this from here.
And from sometimes?
Yes, from here you read out.
Okay. And from where to where? Sometimes.
You read, keep on read. I'll tell you till next page.
Okay,
Till this we can read and see. See, till before activity 5 from the water, right? From till there we will read fully, okay? We will know what they are about to tell. Yes.
Sometimes it may not be possible to separate components of a mixture by winnowing and handpicking. For example, there may be lighter impurities like dust or soil particles in rice or pulses. How are such impurities separated from rice or pulses before cooking?
Yes. Do you understand? 1 minute. Do you understand? While reading, you should also try to understand what they are about to tell.
Sure.
What they are telling.
And they are telling that sometimes when processes like winnowing and hand picking cannot be used
Yeah,
with
correct.
lighter impurities like dust or soil particles in rice or pulses.
Yeah, yeah.
How they're asking how are such impurities separated from rice or pulses before cooking?
Yes, yes. Correct, correct. Read. Go on.
Rice or pulses are usually washed before cooking. When you add water to the impurities like dust particles get separated. These
Yes,
impurities go into water. Now, what will sink in the bottom of the vessel? Rice or dust? Why?
yes, yes.
Should I
Yes,
continue?
can you understand? Can you understand what they're telling?
They are telling that we can separate these insoluble, like these lighter impurities when with the help of water.
Okay. Yeah, correct.
Uh,
This
they are
this
saying that
question, this question.
they're asking that, ma'am, now what will sink at the bottom of the vessel? Rice or
Yes,
dust?
yes. Which one?
Ma'am, it's rice.
Very good. We discussed about this. I'm repeating the question though. Yes. Go ahead.
Why? Have you seen that the vessel is tilted to pour out the dirty water?
Yes.
Yes, ma'am. I also saw.
Yes, correct only, na? Yes,
Yes,
have you seen the
ma'am.
vessel is tilted and the dirty water will be gone and rice will be there. Again, what moms will we do? Moms will do like again they pour the water and they'll
And
keep in
they're
the
gonna
cooker.
use the process of sedimentation.
Okay, yeah, yeah, correct.
When the heavier components in a mixture settles after water is added to it,
Yeah,
the process is called sedimentation.
yes, correct. Now, did you understand what your book says about sedimentation? The same thing we discussed.
Yes, ma'am. When the water along with the dust is removed, the process is called decantation. Let us find a few other mixtures that can be separated through sedimentation and decantation.
Very good, very good.
The
Understood?
same,
Bhavesh, understanding why I'm making you read the book because you'll get exactly the words. That's why I'm making you read.
you're lagging.
Am I audible now?
No, ma'am, you're still lagging.
Okay. Wait. Hello. Hello now.
Yes, ma'am, now you can. Now
Yeah. Why I'm making you to read is because I then only you will get the definitions from the book, exactly the wordings. Then only you will be it will be memorized to you. Because obviously I think so we all will not read the book after the class, right? So it's always better to read the book. Okay,
Okay, ma'am.
fine. The process is called decantation. So like let us find it.
The same principle is used for separating a mixture of two liquids that do not mix with each other. For example, oil and water from their mixture can be separated by this process. If a mixture of such liquids is allowed to stand for some time, they form two separate layers. The component that forms the top layer can then be separated by decantation.
Yes, yes. Understood this paragraph. We this thing we talked, right? We spoke about oil and water. Do you remember?
Yes, ma'am.
Yeah, we spoke about this example in the class. Yes, let
Ma'am,
us
I
again
even
consider.
tried this. I even tried this.
Very good. Yeah, that is very important. Actually, very important example that should be it should be there in your mind. You read from let us again consider.
Let us again consider a mixture of a solid and liquid. After preparing tea, what do you do to remove the tea leaves?
Yeah.
What usually we use strainer to remove tea leaves. Try decantation. It helps a little, but do you still get a few leaves in your tea? Now pour the tea through a strainer. Did all the tea leaves remain in the strainer? This process is called filtration.
Yes. Understood? Now,
Yes, ma'am.
see, there is a flow in this. Can you see that? From the sedimentation, from decantation and to filtration, they have made it as a flow. It is all interconnected process, sedimentation, decantation, filtration, right?
Yes,
They have
ma'am.
explained you everything in one single example, like one single flow. Yes, read ahead. Yes.
Which method separating tea leaves from prepared tea is better, decantation or filtration? Let us now consider the example of water that we use. Do all of us at all times get safe water to drink? Sometimes water supplied through taps may be muddy. The water collected from ponds or rivers may also be muddy, especially after rains. Let us see if we can use some methods of separation to remove insoluble impurities like soil from the water.
Yes, understood this.
Yes, ma'am.
Yeah. So see this. Collect the. I told you to do this thing. No, I told you to do this activity. Collect some muddy water from a pond or river. If it is not available, mix some solid to water in the glass, soil, and then observe. Let it stand for half an hour. Observe the water carefully and note your observations. What will happen? Soil will settle at the bottom of the water, right? You will see the soil go down of the bottom of the water. What will you call this process called? Now slightly tilt the glass without disturbing the water. Let the water from the top flow into another glass. What is this process called, Bhavesh?
Sedimentation.
First process is sedimentation, this one. And the second one, slightly tilt the glass. This process?
Decantation.
Very good, decantation. So this is exactly this thing. Whatever whatever they said in this thing, exactly the same. Is the water in the second glass still muddy or brown in color? Yes, it will be muddy only. Whether the sand may go to the bottom of the glass, but we cannot say they are fully good. They are fully perfect. No, right? So they will be still muddy and brown in color. Now filter it. Did the tea strainer work? Let us try filtering the water through a piece of cloth. The piece of cloth, small holes or pores. So I told you, I think you only asked me what's holes and pores. So here they have given holes or pores, both are same. Remain in between the woven threads. These pores in the cloth can be used as a filter. So they are telling you the small piece of cloth can also be used as a filter, right? So if the water is still muddy, impurities can be separated by a filter that has even smaller pores. So we also spoke about filter papers, right? A filter paper is one such filter that has very fine pores on it. So as I told you, the more and more you make the pores fine, it means the more and more you make the pores small, your filtration will be very, very good. Are you understanding?
Yes, ma'am.
The more and more you make the pore size, that is the hole size small, the more and more the filtration will be good. The filter paper folded in the form of cone is mixed into the funnel. This thing, the mixture is then poured to the filter paper, right? So we also saw about filter papers, and then we deeply saw about evaporation, right? What evaporation, the process of conversion of. So what is vaporization? Bhavesh, what is vaporization? I think for objective test you got this, right?
I didn't. I can't see anything.
No, wait a minute.
It's like a black cardboard.
Bhavesh, you didn't write the objective test?
And that one you said it will come on Tuesday or something.
No. Sunday test I am telling you.
On Sunday test, my mother checked in the tests, but it didn't show.
No, you have not submitted the test, Bhavesh. I mean, you have not written the Sunday test. You didn't write any test on 14th March, that is last Sunday?
Mom, I wrote every test, but this test I didn't see any link to it. Link or something.
Okay, fine. So, shall I extend the time? Will you write?
What?
I want to extend the time actually.
What do you mean?
I mean, like, you didn't write the Sunday test, Bhavesh.
Yes, ma'am.
Last Sunday you didn't write, or it's not written here. It's like view results, and it is showing 0 students wrote. I mean, you also didn't write. So I want you to write this test.
Ma'am, now?
Not now. I'll just make another test, and I want you to write the test. That is what I'm telling you.
Ma'am, now can you say where does it come, like in the test column only?
Yeah, I'll share you it. See you. That is what I'm checking to see your paper. So now can you see my screen?
Yes, ma'am.
See, it is maths. Maths is like one girl has written maths. See, you have to go to, see, like this, it will pop up, Bhavesh. See here, in 6s, you see, it's a group, it will pop up like this. Number system, there is maths. Yeah.
I went to test column, but they didn't show nothing. No tests or something.
See, like this in test. So it is showing here.
Ma'am, for us, it's not showing.
See, separation of substance, 14 March. So I have created the test. Maximum also created the test on 13th April. See, I have given the pass percentage also. Okay, the thing is now I can't edit this. That is a problem. See, I can't edit the start date and anything I can't do. Okay, fine. Okay, you know what I'll do? I'll again repost the same test. I'll repost it today. Tomorrow you complete, Bhavesh. Okay. Tests are very important. Deadline, I'll tell you. You can see the deadline in the same. One day I'll give you. Okay. From today to tomorrow evening I'll give, or from day after tomorrow evening I'll give. Okay.
Okay, ma'am.
I'll make a test. Okay, fine. So we also saw evaporation. So what is actually why I asked you this question? Because in subjective test, in objective paper, I gave you the question, the vaporization and evaporation. So what is vaporization? What is vaporization? What is evaporation? What is the difference between them? Yes, open your camera, Bhavesh.
I think
Yes. Don't search in Google. Don't search in Google. Tell me.
In textbook, ma'am.
In textbook, it won't be there, Bhavesh. I know that. That's why I'm asking you. I'll tell you the answer. Vaporization and evaporations are quite same. The difference between vaporization is, what is the definition of vaporization is? Conversion of any liquid to its vapor form. Conversion of any liquid to gaseous form is vaporization. Whereas evaporation is conversion of water into its vapor. When you talk only about water,
So, ma'am, did you say liquid or solid?
liquid, from liquid to gas.
No.
See here, water is a liquid or gas or solid here. Water is a gas, liquid, right? And vapor is nothing but gas, right? Gaseous form, right? So instead of water, if you put here liquid, and instead of vapor, if you put it gas, then the definition will change into vaporization. That's it. The process of conversion of liquid state into its gaseous state is vaporization. Okay. But if you want to specify it more specifically, if you want to tell, like, you can tell water. If you want to convert the water into its vapor state, it's called evaporation. When it is water and vapor, it is evaporation. But when it is common, I'm not telling you particularly water only, oil only, not like that. Particularly, I'm not telling, but I'm telling you commonly any liquid form into its gaseous form means it is vaporization. Okay, now you understood, or it's still confusing?
It's not confusing. I understood.
It's good, right? Fine. So yes, the process of evaporation takes place continuously wherever the water is present. So we saw this, right? We saw a video obtaining the salt from the seawater.
Yes, ma'am.
So see here, from here, I think we want to see use of more than one method of separation. We studied some methods for separation. See here, we studied some method of separations of substance from their mixtures. Often, one method is not sufficient to separate the different substances present in the mixture. In such situation, we need to use more than one method. It is quite common, right? So we saw now separating the salt and sand. We are doing two processes, right? First, we are pouring the water. Then we are boiling the water, and through the condensation, we are removing the water from the sand. And then by the filtration, we are removing the sand particles, right? So we are using two methods, right, Bhavesh, to separate salt and sand.
Yes, ma'am.
So that is what. Yes, sure. Yes, sure.
Yes, ma'am.
Yes. So I was telling you about, like, we often use 2 or 3 methods for separating some substance. Like, for example, we discussed about salt and sand separation. We used two methods, filtration and condensation, right? So like that, they are telling the same. We studied some methods of separation, but often one method is not sufficient. We want one or more methods to separate the things, right? That is what they are telling now. So this thing we saw, right? This evaporation and condensation process. Yesterday we saw in the class. Have you remember?
Yes, ma'am.
So here the part at here, see the ice cubes are present on the lid. So this is also called as condensation. The condensation is also called as cooling process. Okay, the condensation is also called as cooling process. We saw briefly about this experiment yesterday. So now, can we dissolve any amount of substance? See, in chapter 2, we found that many substances dissolved in the water and form a solution. Many substances dissolve in water. Its salt will dissolve, sugar will get dissolved. Many substances are there that can get dissolved in the water and form a solution. We say that these substances are soluble in water. So whatever it is getting diluted in water, getting dissolved in water, we say them as soluble substances in water. Am I right? So what are the substances that are soluble in water? Those who are completely, they are what? Broken down into small parts and they are completely mixed with the water. Those are called soluble substances.
For that reason, we call water a universal solvent.
Universal solvent. Yes. So that is why water is called as universal solvent. What will happen if you go on adding more and more of these substances to a fixed quantity of water? For example, I want to dissolve sugar in water. I am adding 1 spoon of sugar. I am stirring it. The sugar is getting dissolved. I am adding 1 more spoon of sugar. I am mixing it. Yes, sugar is still getting dissolved. I am adding 3 spoons, 4 spoons, 5 spoons, till 7 spoons. The sugar, whatever I'm adding, is getting dissolved. And after the 7th spoon, 8th spoon I'm adding, the sugar is not getting dissolved. What is the reason behind it?
Because the water cannot dissolve anymore.
Why? Because the limit exceeded, right? The limit exceeded. The capacity of the water is to a certain level only. To a certain amount of sugar only, it can dissolve. It cannot dissolve how much ever you give it, it won't dissolve, right? So that is what we are going to see deeply here. So activity. So you will need a beaker or a small pan or a spoon, salt and water. Pour half a cup of water in the beaker. And only half a cup of water you should pour. But they are adding one full teaspoon of salt and stir it well until the salt dissolves completely. Again, add the full teaspoon of salt and stir it. Going on adding salt, 1 teaspoon at a time and stir it. After adding a few spoons of salt, do you find this some salt remains undissolved, settled at the bottom of the beaker? Right? So you have only half, you can say 1/3 of water only it's there, Bhavesh, in the beaker. But I am keep on adding lot of spoons of salt. I'm stirring. Will the salt get dissolved? No. And you will see the salt remain in the water. Like that it will be remained. Right? Yes. So if S, this means that no more salt can be dissolved because the amount of salt, the particular minimum amount of water can dissolve is exceeded. So it cannot dissolve more amount of salts than its level. So in the amount of water I have taken, so the solution is now said to be saturated. So what is saturated solution? The solution which are called as saturated has attained the maximum level of which it can dissolve any more solid substance, right?
Yes, ma'am.
Can you define the saturated? What is mean by saturated liquid? I can tell you. Yeah.
Ma'am, saturated means the limit where you cannot add any more soluble substance to a liquid.
Yes. I hope you can see the screen. Saturated solution. What you can define? If a solution is said to be saturated, it cannot dissolve any more solid substance. That's it. If the solution is said to be saturated, it cannot dissolve any more solid substance as it attained its maximum saturation level or point, you can say saturation point. Understood? You can take this as a formal definition. If a solution is said to be saturated, it cannot dissolve any more solid substance as it attained its maximum saturation level or point. Right? So I am having, take like, I have a beaker. Oh my God. I have a beaker. I have water in this. Okay, I have water till here. Okay, till here I have the water. Remember, till here I have water. I am adding 2 spoons of water in this. Sorry, 2 spoons of salt in this. Will this amount of water able to dissolve the 2 spoons of salt?
Yes, ma'am.
Yes. So I am having one more beaker. I am having water till here only. Very little water. Okay. I am adding 4 spoons of salt. Can this dissolve?
No, ma'am.
No. So how you are telling, Bhavesh, like, ma'am, this right hand side beaker can dissolve 2 spoons, but the left hand side cannot do. How? In what basis you are telling?
Because we have more solubility content and we have less liquid.
Very good. So saturation level is always based on 2 factors. What are those?
Liquid insolubility.
Yes. Amount of liquid used to dissolve
solubility substance.
solid substance, you can tell. And also amount of solid substance liquid. Right? These 2 factors more saturation level. Here, the amount of water is high, the number of spoons are very low, so it can easily dissolve. But here, the amount of liquid is very, very low, and the number of spoons is very, very high, so it cannot dissolve. Understood? Yes, Bhavish, understood?
Yes, ma'am.
Okay, fine. So this is all about saturation level. So here is the hint. So as to what might have gone wrong when Haley tried to recover large quantities of salt mixed with sand. Perhaps the quantity of salt was much more than that required to form a saturated solution. The undissolved salt would have remained mixed with the sand and could not be recovered. She could solve her problem by using a larger quantity of water. Suppose she did not have sufficient quantity of water to dissolve all the salt in the mixture. Is there some other way that water could be made to dissolve more salt before the solution gets saturated? Did you understand what they are telling?
Yes, ma'am.
So where is Peheli first? Peheli asked some question. I don't know. I don't know where it is. Where it gone?
On page 27. Activity A. Activity 8. 8. 8.
Okay,
The last paragraph. Last paragraph. Here's a hint.
Let us try out Peheli. No. Yeah, I understood that, but Peheli's question before. Okay, fine. So Divi spoke about saturation. Here is a hint as to what might have gone wrong with Peheli trying to recover large quantity of salt.
Is this one you are asking? Suppose she did not have sufficient quantity of water to dissolve all the salt.
Yeah.
It's in the right side.
Yeah, correct. Yeah.
The top of the activity 9.
Yeah, there only. Is there some other way that water could be made to dissolve more salt before the solution gets unsaturated? Yes, you have.
Yes, ma'am. We need to add like more liquid.
But see the condition. See the condition is she did not have sufficient quantity of water to dissolve all the solid in the mixture.
We need to add more liquid.
No. So see, the condition is that she did not have the enough amount of liquid. So what she will do then? You can heat it. You can heat it. If you heat, it will get dissolved. We'll see how it is happening. See activity 9. Take some salt water in the beaker and mix the salt in it until it cannot dissolve any more salt. So you have to basically prepare an unsaturated solution. Understood? Take very little amount of water but add more salt so that the salt cannot be dissolved by the water. Make it unsaturated. Okay. Now add a small quantity of salt to this saturated solution and heat it. Okay. What do you find? What happens to the undissolved salt in the bottom of the beaker? Does it dissolve? Yes, I think you have to do this experiment and see, Bhavesh. Then you will understand very better.
I did it.
Okay.
You
did it already.
Homework.
I gave his homework.
Yes, ma'am. You told me to mix the.
No. That was that homework I gave. I think for the next can you separate the salt and water from the salt from can you separate the salt from water? I think for that I would have given. Yes, starting I have given. But the condition you didn't understand. You have to make it unsaturated, Bhavesh, so that the salt will not get dissolved anymore. You have to take a lot of salt and very little amount of water. You have to make it unsaturated solution. Understood?
Okay, ma'am.
Make it unsaturated solution so that the salt will remain at the bottom of the beaker in the water only. Water cannot dissolve any more salt. So now heat this beaker. Okay. Now if you heat, what happens to the undissolved salt in the bottom of the beaker? It will get dissolved. Now you go and do this homework. In your home, you will find it. If yes, can some more salt be dissolved in this solution by heating it? Let this hot solution cool. Does the salt appear to settle at the bottom of the beaker again? So do all these activities so you will understand. The activity suggests that the larger quantity of salt can be dissolved in the water on heating. This is very important point. So if they ask you, they cannot, so they may ask you if they cannot, add more salt to the water and the water quantity is very, very low. So, but still I'm telling I want to dissolve more amount of salt, but I don't have water. So you will suggest me what? Heat it. Take an unsaturated solution and the salt particles will remain in the water because it is an unsaturated solution and I want to dissolve the salt fully. So what will I do? I'll heat the liquid. If I basically heat, yes, it will get dissolved. You will see the salt are getting dissolved. You go and do this. You know how to prepare. Your mother will be preparing this jamun, right? Gulab jamun. So have you seen that she will put more sugar in the water? The sugar that she is adding will be more amount, but the water level will be less. Did you observe that? Yes. You go and ask your mother today. So today 2 homeworks. We'll stop here. Today 2 homeworks. So first homework is do the experiment. Do the experiment, whatever we said, I'll post in the group also, okay? And then you ask your mother how to prepare gulab jamun's jaggery. That is basically, what they will do. They will take large amount of sugar, Bhavesh, but the amount of water is only 1/4 of the sugar. Listen carefully, 1/4 of the sugar. Amount of sugar will be very low, high, but water quantity will be very low. And how they will dissolve, they will heat the jaggery. When they heat it, you can see that sugar getting dissolved in the water, but the syrup will be very, very, very thick. And that is how the gulab jamun's jaggery is made. Right? To ask your mother, she will explain you. Okay, that is your homework. Okay, I hope we saw something today, understood, right?
Yes, ma'am.
We can end the session, right? Okay, bye. I'll post the homework. See the group.
Okay, ma'am.
Bye.
By the way, did you make that group, PD group or something?
Yes, Bhavesh, I made the group, but only 3 people joined. I don't know why. I made PD, summer camp, and Manisha ma'am has shared that group link in all the groups. 6th group, 7th group, and 8th group. I'll share once again if you want. Please join everyone in the group and submit the homework. Okay, I'll tell again the group. Okay, bye.
Bye, ma'am. Have a good day.